Nucleic acids are large molecules that contain a whole bunch of nucleotides connected to each other by phosphodiester bonds. Phosphodiester bonds are also called phosphodiester linkages. And I'm going to draw in this video, I'm going to draw the phosphodiester bond so you can see exactly what it looks like. So these are two individual nucleotides and when they come together to form this phosphodiester bond to make a nucleic acid, they line themselves up so that the phosphate group of one of the nucleotides is lined up with the OH group of the other nucleotide. So this is the point where the two are actually going to connect to each other. Now I actually have to reorient the oxygen atoms on the phosphorus here. The oxygen atom with the double bond needs to actually be positioned out of the way here over to the left like that. The connection that is formed is going to take place just like this. So, oops, I grabbed a hydrogen on accident. So it's going to look just like this right here. And this that we just created, this right here, is the phosphodiester bond. Sometimes people highlight it all the way, like all of this whole area here would be the phosphodiester bond or the phosphodiester link. We'll just sort of go like this. And then it just kind of continues in this same pattern. So the next nucleotide would be connecting itself to this point, and this creates sort of a zigzag shape to the nucleic acid. This is a lot to draw, like there's a lot of atoms here. So there is a shorter abbreviation for a nucleic acid. I'm going to draw over here. In this shorter abbreviation, we will draw the sugar molecule. It's right there, kind of in full with the 5-membered ring. And then attached on this point of the sugar molecule, this is where we have the CH2 followed by the phosphate group. So that's typically going to be represented using a bit of line notation, where we're going to have this, this part that represents this bend here that represents the CH2. And then this circle, we're going to put a P inside that circle to represent the phosphate group that's attached right there. We also want to represent the base that's attached to the cyclic part of the nucleotide. That base is attached in this point right there. I don't know what happened to my phosphate. There we go. So we're going to just draw like a point of attachment for this base. And I'm going to use a box to represent the base. And a lot of times inside this box, we'll just write the 1-letter abbreviation for the base. So maybe this is the base, we'll abbreviate it with the letter C. And I'm going to make my phosphate a little bit bigger. The second nucleotide is going to be attaching itself at this point right here, and it's going to be attaching itself with that phosphate group. So I'm going to draw another big circle here to represent the phosphate group. That one ended up really big, and then we'll have that bend, that same little bend right here, where we connect to another 5-membered ring. And then also on that 5-membered ring, we're going to have another base. Let's put an A right there. And let's just go ahead and do one more. So the connection is going to be at this point. This will be a phosphate group. We'll put a little bend in it, and then we'll draw our 5-membered ring, and then let's do the base T. So we've got something that spells cat. At the very end of the nucleic acid, the very last nucleotide down here is going to have an OH group, just like this one right here. So the point of connection for this nucleic acid just kind of runs along like this. This is sort of the backbone or the skeleton. We can assign some numbers to the carbon atoms that are associated with this sugar molecule. This is something that we learned when we were talking about carbohydrates, so it might be pretty rusty to you, or it might be completely unfamiliar to you. But when we're numbering the ring of a carbohydrate, we start numbering on the very right-hand side, 1, 2, 3, 4, 5, and we number outside of the ring like that. So I'm going to put these numbers on here for a reason. Once we get them all written down on here, then I'll talk about why. Put these numbers on like this, 1, 2, 3, 4, 5. So one of the pieces of notation that we use when we're talking about a nucleic acid is we talk about the 5' end of the nucleic acid, and we also talk about the 3' end of the nucleic acid. And that notation, 5' and 3', has to do, or it comes from, the carbon atoms that are at the top and at the bottom of this backbone or this skeleton. So up here, this is what we would refer to as the 5' end of this nucleic acid. And down here, this is what we would refer to as the 3' end. Now, why is this useful? Well, typically when we are abbreviating, when we're writing the structure of a nucleic acid, we just simply use the one-letter abbreviations of the bases that are attached to the nucleotides, and we list them in order from 5' to 3'. So the abbreviation, if we really wanted to abbreviate this structure, because even this shorthanded structure is still pretty tedious, the abbreviation is going to start at the 5' end, and we're just going to write 5'. This little apostrophe looking thing is pronounced prime. We'll put a dash, and then we're just going to list every single one of the bases, the one-letter abbreviation for the bases, in order without separating them with any kind of dash or anything like that. And then when we get all the way down to the end, then we'll say that's the 3' end. So we always abbreviate these nucleic acids using the one-letter abbreviation of the base, starting at the 5' end and working our way down to the 3' end.